Hi everyone, my name is Anand Singh Yadav, and in this video, which is mock video, and in this video, I'm going to talk about covariance and contravariance. This is one of the important topics when we talk about generics and Java. Okay, so let me first share my screen and start about this first. I hope my screen is clearly visible. Now, let me start one project. Let me create one project here. That is covariance and uh, okay. So I have created with this name. I forgot to take the okay. No problem. So let me take here one class. I can create one class here. So the class name is array refiner. Array refiner. So I'm taking here bracket from models and models. Let me take here from the array. Different unit content. So why I have taken this array refable, I will tell you about it. So don't don't ask me right now. So I will tell you later on why I have taken this array as this class as array refable. Okay. So I forgot to take main method. So let me take the main method here. And I'm writing here very basic line. This is belonging to the fundamental part of Java, like very basic part of Java. So let me like a super class reference, super class reference variable can point to child class object. Okay. So super class reference variable can point to child class object. Okay. I hope this is very basic part of Java. So let me clarify it why I have written this. So let me give some clarification on it. So as we know, object with O capital, what is this? This is nothing but this is the parent class. This is the parent class for all the class in Java program, whether it is predefined class or whether it is user-defined class. So let me take a user-defined class as a student, user class as an employee. So for this student and employee, the super class will be always object for every class, right? I'm not like telling only for student and employee. Even for every class, like whether it is user-defined or it is predefined. So I have one predefined class, let's say number. So this number class, right, uh, will also like for this number class object will be the parent class. But and again, this number class has it is like number class is a numeric kind of class. So it has some numeric subclass. So if I talk about integer with I capital, float with F capital, double with D capital, and the long with L capital. So here as you can see, these are all the child class for number. So number will be superclass. So from this line, just concentrate on this line. So it is saying superclass reference variable can point to its child class. It means if I talk about this object, so object is the superclass for all the class in Java. So it belongs to java.lang object package, right? Java.lang package it belongs to. So if I talk about this object, so object belongs it's a like parent class for all the class. So it is saying a superclass reference variable can point to child class object. So this the reference variable this object can point to either student, employee, number, integer. It can point to any of its child class. Got it? Or its on class as well. So here if I talk about number, so number, right? It can point to like it can point to the number reference variable can point to its any of its child class, whether it can integer, double, and more. Got it? So this is how I hope now this line is clear to everyone, right? This line is clear to everyone. So let me from this line, let me take a number and number. So what does it? If I talk about this number, what is it? This is the object or reference value. Tell me. So here, let me clarify on it. So this is the reference variable. Okay. this is the reference variable. Number is reference variable of type number. Okay, of type number. Why it is? Because uh, how we take reference variable? So if I talk about reference variable, so we take class name, right? And the reference variable name, right? In this way we create the reference variable. And it created at compile time. It created at compile time, right? At the time of compilation, it is, right? At the time of compilation, reference variable is created. So if I talk about how do we create object, so for creating object, what we use new keyword. We use new keyword. New, then class name, class name. Okay. So this there will be class name, not class name. Okay. So new dot class name, and then if we have any parameterized constructors, so we also take list argument list. It's depend on us. If we want to initialize instance variable at the time of object creation, then we can. Okay. So this is how we create, right? And we can refer reference variable attributes, right? So this is the reference variable of class. Like in this way, like we create out. In this way, we create out. And one more to point, I just want to tell you for this concept. So object creation always, object creation always happens at runtime. This point, I hope everybody knows because this is very basic concept of Java technology. I have revised it, but everybody must know about it. Okay. So I hope this point is clear. Let's come back to the previous topic. So here at line number, uh, just a second. So here at line number 23, so like, are you able to see, is there any new figure? No. So therefore, this number is a reference variable of this type, this number. This is the class name. Okay. So this number is a super class for all the numeric like subclasses. So if I talk about integer, float, double, long, for these classes, this number is a super class. So its reference variable. So its reference variable is number. It can refer to any of its child class. So how do we create the object of child class? So we use new, and the child class is integer, and we can provide some number, etc. I am correct. So right now it is deprecated, so don't focus on it. The main agenda is to see like how to create the object. So we take new and then we take the class. Got it? In this way we create the object. But right now this is deprecated. So let me take some right one. So integer dot value. So this using this value method, what we do? We using this value we convert the primitive to the object. Okay. So now, right now, this is the reference variable of super type. It is referencing to the object of child type. So integer is a object. This integer is a child object in the number. Okay. And the child class object. And if I print this result number, so let me run this code. So as you can see, 45. Got it? And let's say if I do the same thing for some other class of number, subclass of number. So this is flow. So let me be careful. Here 90.45. So I have taken here the float value. Right? So float object. So this goes because this is also the object of like subclass object of number. Right? So I hope now this line is very much clear to everyone. So superclass reference variable can point to child class, any child class object. Okay. So here as you can see, I'm taking child class object of integer and float. Okay. And this is also in the case of array as well. So if I take array example, so array, same with array, right? If I write here, same with array. 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 So So let's say I'm taking number array, num array, and with some. So when we create the array in Java, so we need to define the size as well. So let's say I'm defining the size here. 3. So what it has been created? So it has created, let me also tell you, so it has created array of 3 references of type number. So we have created 3 references of type number, right? So the first reference is num of 0 at index 0. So we can refer any subclass of number, any object of subclass, right? So we have a integer, float, double, right? So I'm referring here integer dot value, and I'm writing here let's say 50. Okay, I'm writing here 50, and at index 1, I'm taking here let's say float. The float is 4.9, and at index 2, I'm taking here double. I'm taking here double. So this double value is something 30.45. This is the double value. So I hope now it is very much clear, because superclass reference variable can point to any child class object. So as you can see, this is the reference variable of number type, right? This is again the reference variable of number type. This is also the reference variable of number type. It can point to any like child class object, right? So we can write here integer, whether we can write float, double, dot, anything. Got it? So got it. So this is how we can. So let's say if I print it number num and it's not order, one number. So let me give some time here. Okay. So as you can see, each and every value is done. Okay, so this is how this superclass reference variable can come to chart. Let's now discuss one very important analogy. You will get to right. So let's discuss very important analogy. Okay. So from the above learning, like from the above examples, right? So we need to understand this analogy. Like you can easily able to like visualize this. Here, let's say I'm taking here integer. I'm taking here int array. I'm taking here int array. At the time of declaration, I'm also initializing the value. Let's say I'm taking here 14, 15, 16, 17. Okay. Just a second. So 40, 50, 60, 70. So here at line number 49, what I have created? Everybody tell me. So at line number 49, I have created uh, array of 3 integer objects. Okay, not 3, there is 4. Integer objects. I have created array of 4 integer objects. Got it, everyone? So now, what I'm going to do, I'm going to take here number array as well. So number. So as we know that one superclass reference variable can point to the child class object, then any child superclass array, right, can point to its child class array. From this, once any variable of superclass, any reference variable of superclass can point to child class, then like superclass the reference variable array superclass array reference variable can point its any child class array object, right? Child class. So let me write here so like you will more understand it. So here I'm writing if S is super type and T is subtype, then using reference variable of S type that we put enter can point to object of can point to child class object of type. So the same thing I have repeated the 21 line 21 line, right? I have repeated in very simple way. If S is a supertype, right? This is one and T is a subtype. Then using reference variable of S type can point to the child object of type T. Got it? So the same line, what I'm going to do, I'm going to copy paste it so that you can understand that why I am. So here, here, so I'm repeating again. If S is a supertype and T is a subtype, then using reference variable of S array type can point to the child class object of type T array. Got it? It means if number is a if this number is a super class this number array is a super class array reference variable, right? So then it can point to the child class array reference variable, right? So here the reference variable is for the like child class is int array. So there is no problem. It is referencing that. There is no issue. Okay. So if I so there is no issue, right? There is no issue. If I change the value, let's say now inside the we have copy pasted the entire value this to this number. Now at line number, let's say at line number at index number 0, what I'm going to do, I'm going to change the value 40 to let's say 20. There is no problem because this is all these values are integer. These values are integer. Is no issue. But once we are once what we take at index number 1. Now what I'm going to do, I'm going to put 45. This is this great problem? Then is this great problem? I don't think. So let's run it and try to know like what kind of problem it is going to put. So this is going through one exception. Array store exception. Why this is creating? Why this is creating? Because in the case of array, what happens? In the case of array, let me write here one line. In the case of array, type information is not available to, or we can say compiler does not have any type information. कंपाइलर के पास टाइप इंफॉर्मेशन नहीं होता है, राइट? कंपाइलर डज नॉट हैव एनी टाइप इंफॉर्मेशन, राइट? बट in the case of array, right? In the case of array, when at the time of object creation, type information is available to runtime system. So let's understand now. So once we have done, we have put 20 at index 0. There is no issue. Compiler saying no problem. I don't have problem if you are putting 20 or 20.45. I don't have any issue because I don't have any type information. I don't have any data type information. But let's copy this entire thing and come to the Sublime Text Editor. So here, just a second. Okay. So here, what is happening? So once we have done the compilation, once we run this program, after running this program, what is happening? This array reference we have given to number array, right? We have given to super type of number array reference. So when we are changing value of index 0, 40 to 20, there is no problem because this is integer. Runtime system saying I know just a- runtime system saying I know because runtime system has, when we run this program, so runtime system has type information. It is saying this is the integer type, this is the integer type of num array. So I don't have any problem. You can write 20 as well. Right? But when we at line number 57, when we are putting this double value, so this runtime system saying now you are trying to put double value here, but this is not allowed, right? You cannot make me fool. You have made a compiler fool, but you cannot make me fool, right? So this will create a problem. This will say array store exception. This will throw here array store exception. Array store exception. Array store exception. Or this is also known as heap pollution. This is known as heap pollution, right? This concept, like this is known as heap pollution. Why? Because if like here integer is there, if you are putting double value, this is not allowed, right? Later on you can put anything, right? You can put like string as well. So runtime, in the case of array, runtime system has type information, right? So we can write here one important thing: data type whose type information is available to runtime system is known as v5 v5. Therefore, 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 still array is v5. V5. I hope now this point is clear here. Why I have taken this array as this class as a array. So because array is a v5 type. For array, type information is available to the runtime system. But for compiler, it does not have any type information, so it will not create problem. But in the case of runtime system, it will say this is not a problem. Okay. I hope this point is clear to everyone. This is array defined. Got it? In the case of variable. So let me revise it very quickly. So this is all about. This is the important line. Superclass because variable can point to child class object. So here I have taken none, and this number is a reference variable of number type. So it can have any child class object, integer, float, type. In the case of array as well, so I have created the array of length 3, right? And it can have any like any of the child class objects, so integer, float, double, type. We have printed. But we have also taken one error. Let's say we have an integer array, and these all are the values inside the integer array. And we are referencing this entire array to the super class. So there is no issue we can have because super class reference variable can point to the child class. But when we are changing the value at index 0, which is integer, so there is no problem. This is integer. But when we are changing at 57 line, at line number 57, which is index 1, this is the double value. So it will say this is not allowed because for array, the runtime system has type information. So therefore, this will create the problem. Got it? This point is clear. Now let's create a different uh, class that is collection not v5. Okay, I hope from this class name you will get some idea. So let me quickly create one method. And here I'm taking here, let's say list of integer. List of integer here. Very list. Okay. So why I have taken this? So you have a basic idea of generics. So this list can only have integer type of value. This can only have the integer type of value because due to the generic concept, it will prevent you not to have any value like which is not integer, right? Which is not integer. So if I add here in place, add something 30, copy paste it. Yeah. So I have added 14, 15, 16, 4 elements to this array. To this list. And if I add, let's say, if I add here float value, let's say 40.55. So this will say, right? This is not like allowing you. Why? In the case of collection, what happens? So type information is available type information is available to compiler for check. For checking. This is the important point for checking. For which? For checking. Once checking is done, it drops the type information. It does not have any information. Compiler does not have any information about the type. So therefore, it is only for the check. So this is not allowed. If you add here linked list or some other data type, let's say I'm taking a string as a, this is not allowed. Got it? Why it is not allowed? Because type information is available to the compiler for checking out. Okay. So let's take an analogy. Let's take I have a number. What I have? So I have list of number. I have a list of number. So this is the number list. And as from the array list, right? From the array. So we know like this, like here as you can see, this is a super class array. Like in super class array, it can point to the child class array. So therefore, there is no issue. But in collection, what happens? If I take a int list, if I take an int list, this will create problem. This will create problem. Why this is create problem? What is the reason behind it? Tell me. So the reason is because type information is available to compiler for check. This is true because this is number is a super type, but integer is a subtype, subclass of number. So this must be allowed, right? This must be allowed. So why it is not allowed? What is the reason behind it? So let me tell you about it. So as of now, what I'm going to do, I'm going to. So what happens in the case of collection? So type information. So there's a type region. There's a type region. So what happens? So compiler has type information for checking. Compiler has the type information only for checking. Once checking done, drop. It's drop. It dropped, right? Once checking done, it dropped. Therefore, 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 type information is not available to runtime system. Okay? So इसी वजह से क्या होता है कि रन टाइम सिस्टम के पास टाइप इंफॉर्मेशन नहीं होती है, राइट? अब क्यों नहीं होती है उसका भी एक रीजन, राइट? Let me tell you. So type region, what happens? Like initially compiler has type information for checking. Once checking done, so this type information dropped suddenly. And type information इसी वजह से क्या होता है कि type information is not available to the runtime system. Got it everyone? I hope this point is clear. और अगर ऐसा ना हो, let's say this line, let me copy this line. Let's understand this. Let's say this if this works. अगर ऐसा हो जाए कि लाइक ये वर्क करे तो क्या होगा इस केस में? तो इस केस में क्या होगा? लेट्स से हम्म, इस केस में क्या होगा? सो दिस इज राइट नाउ दिस इज द इंटीजर, दिस इज इंटीजर, ओके, right now this is integer. So if it is okay, there is no problem. If I make it okay, if I make it okay, let's say it is working, it is working. So what will happen in future? What will happen? We can put, we can put, we can put uh, double value, double value to it, double value to it, right? We can put double value, right? That will, that will create the pollution, right? The pollution, right? Before this, let me also add here one more line. So why this type information dropped suddenly? Because due to this maintenance issue, right? Because it is heavy for maintenance, heavy to maintain, right? Heavy to maintain. But this type information is quite heavy to maintain. Therefore, it is dropped, right? इसी वजह से type information is not available to the runtime system. So once this type information is not available to the runtime system, so we can say data so collection is non-verifiable type. Okay, this is non-verifiable. Why? Because it does like type information about collection is not available to the runtime system. Got it? Therefore, I have taken this class name as the collection event. But let me take, I was talking about one analogy. Let's say if this is okay, if it is like, if type information is available to the runtime system, right? Not that like that. Let's say right now, initially what was happening, this is not working. Let's say if it is working. So what will happen? We can put double value because double value is a subclass of number, right? Double is a subclass of number. We can put double value. So this will create the heap condition, right? We can put integer, integer value, right? We can put integer value once when we put integer value. So we can say there is no problem. There is no problem. We have no problem here. But when we put double value, then right, then it will create the function, right? It will create the function. I hope these points are quite clear to everyone. Got it, everyone? Okay. So therefore, and once heat pollution, or let's say heat pollution is also there, or when we go for the reading thing, when go for reading, when go reading, let's say I'm taking a number, right, and number as num and the number list. Okay, so I'm taking is right. Just a second. I don't have number. So right now, so I have commented therefore the error is correct. So if I read it, so if I take a system dot out and none, so what will happen? This double value, when double value will come, so it will crash the entire system. This will create the class cast exception. Class cast class cast exception. This will say this is not allowed because we are working on integer, so like we cannot like. So this will create class cast exception. Okay, this will create class cast exception. If I take an integer, right? Or if I take a let's say int list, okay. So this will create class cast exception. Got it? I hope you have understood why array is definable and why collection is not defined. To understand why it is happening, why like we are not like why collection is not definable, why array is definable. So there is a concept covariance and contravariance, right? There is a concept covariance and contravariance. let's understand about it. Okay, so you will be have some idea like why it is like that. So before that, let me share my screen, and so here let me open collection class Java docs. So here we have a collection class. Collection is not a class. This is the integer. This is the interface. Okay. This is the okay. So here, as you can see, this is interface, and so like here you can say this is the subclass of the collection. And the most important thing that I want to show you, that is this collection, and this question mark extending. What does it mean? Do you have any idea about it? Do you have any idea about it? Why we have taken? Like, why have we have taken? And if I talk here, if I talk interval, so as you can see in the case of interval as well, there is a for each, like consumer, this question mark. So what does it mean? Right? So let's understand more about it, right? Let's understand more about it. So now I'm going to create one class here. The class name is Covariance. Right. I have created one class at Covariance. And let me create main method here. So in the case of covariance, what happens actually? Let me copy paste this list. Okay. So what happens in the case of this covariance? So let's say I have a list of numbers. I have a list of numbers, right? And this is the list of integer, which is the sub list of number, right? So here I'm taking here number list. Again, same analogy I'm taking here. So if I reference child class, or like a super class to the child class list, so again this will create problem. You have understood why it is creating problem, because the type information is not available to the runtime system. Therefore, it is creating the problem. Okay, got it? So therefore, it is creating the problem. So what we can do, because type information is available to the compiler, so this is right. So what is the solution for this? So if I create the list, let's say if I create the list in such a way so that, let's if I create a list where it can hold list of number, where it can hold number, and or we can say or any child class objects, child class objects. Okay, so here, so how can we create it? So in the covariance, what will happen? So we have this question mark and using extend. So now as you can see, once I have used this question mark and extend, this has been removed. So what it has been like, what happened actually in like in the previous situation, it was not working. In the previous condition, when I was writing here number and the number list, or you can say number numbers equal to int list. So in this case, as you can see, it was not working, right? So it is not working because you have understood the reason. But in this case, when I use this question mark extend number, so this is the concept of covariance. What happens? We have provided this information to the compiler. To compiler, we have provided this information. Hey compiler, what you need to do, you need to keep this information, right? What is that information? You don't need to drop this information. You just need to keep this information in your mind always, right? So, so it is saying it can take the list of number or any child list. any child base of beta. So here we can see it is an integer, so it is taking integer is a subclass of number. So therefore there is no issue, right? There is no issue. There is no issue. So if I print it, so we have a, let's say, number, none, okay, and we have a number list. Okay. So if I print the entire result, let's say none. If I run it, there is no issue. It will it will run. Okay. So after this, the important thing. So this point is clear. Now let's take one analogy. If I write any value to this, like this number list. So let's say this to this number list, what I'm going to do, I'm adding some element. So number that just add, I'm adding here, let's say 45. So this is creating cloud. Also, this 45 is an integer. Okay, so 45 is an integer, or this integer is a subtype. Although it is creating cloud. Why? What is the reason? Because compiler knows. Because the reason is compiler knows about type in, information in the case of covariance. Okay, in the case of covariance. But but runtime system does not know. रन टाइम सिस्टम को पता नहीं है, बट कंपाइलर को तो पता है, लेकिन रन टाइम सिस्टम को पता नहीं है. इसी वजह से रन टाइम सिस्टम बोल रहा है आई डोंट नो लाइक व्हाट इज दिस देयरफॉर राइट देयरफॉर इट इज क्रिएटिंग प्रॉब्लम. Actually I have actually this is the entire wrong statement. Let me come it again. So what happens, like once we have provided the type information, so in this case what is happening, as runtime system does not have any information about this, right? Any information about it. Therefore, compiler prevent this. In the case of covariance, we can only read, not write, right? Why this is happening? Because if it is available, because type information is not available in the runtime system. If it is available, then what will happen? We can add a double as well. We can add a float as well. So this will create the problem. This will create the heap pollution, right? So therefore, writing is not allowed in the case of covariance. So here I'm writing here only reading is allowed in the case of covariance. Okay. And the second point, if we allow the writing, right? Why writing is not allowed? Because if I allow the writing, so runtime system does not have any type information. So this will create the problem. Therefore, compiler prevent it. So so what will happen, that the runtime system will create arrays to like some exception, right? They will create some exception. So therefore, addition is not allowed. Okay. So we cannot add any element to it. I hope this point is quite clear to everyone. Okay. Any issues till this point? I don't have any. If you have any issue, you can type in the chat. Okay. So yeah. So this may lead to heat pollution if we allow, right? So let's now talk about. So in the case of covariance, you just need to understand only reading is allowed. Only reading is allowed. Okay. So due to the type erasure, like this will create some issues at the runtime, right? So therefore, reading is only allowed. So let's now talk about contravariance. Contra. Okay. So what happens in the contravariance? Let me quickly take and method, and let me copy paste this list. Okay. Copy paste this list. Yeah. So I have taken this list, and what I'm going to do, I'm also going to take and log list as well. List of log. Yeah. List of log. List of log. So let me have some boundary here. So this is log list. Got everyone? Got it? List of log. Now it's okay. There's no issue. So I have created here integer list and long list, which is the subclass of number. This is the subclass of number. I'm going to create one static method where void. So we have to construct static line copy. So what I'm going to do. So I'm going to take list and we are pushing that. So this will be the source. And again, I'm taking one list. And this will be as destination. Okay. So what this method will do, it will copy the source and it will paste to the destination. Okay. So as we already know, so I have created this first like variable, like this argument I have taken. Why we have taken this parameter? Because it can use for the reading purpose. So like for reading purpose, so it can take either so we can use here extents, and we can take either number, list of number, or any subclass of number. But for writing, we have a contravariance. So apart from this extent, we have a super. So what will happen in this case? Let me use some this font size. So what will happen in this case? We already know about the four variables. So we are not talking about this. But in the case of contravariance, so what will happen? So either it can accept the list of number or any superclass, right? Any list of superclass, any list of superclass. But reading is not possible. Why reading is not possible? I will tell you, because reading is not possible. So let's say if I read four number or none, or if I take your destination here, destination, if I take your destination. So as you can see, it is creating problem. It is saying like, because why reading is not possible, because uh, this is not confirmed, like every time there will be number, there may be any superclass as well, there will be any list of superclass as well. So therefore this is the issue here. This is not confirmed, like every time there may be number type like this, right? So the issue is there. This is the issue, but they want one solution as well. So if I take here object, right, because object is the class of parent class of all the class. So this is the solution in the case of object. There is no issue, but but with the object we need to do lot of downcasting. So this is not the ultimate solution, right? This is not the ultimate. We need to do lot of downcasting. Or if we are doing downcasting, then this is not the concept of jumpers, right? So therefore we can say reading is not like reading is not allowed in the case of. So we can write here reading is not allowed in the case of contravariance. Okay, reading is not about the case of contravariance. This is the one. Now, what I'm going to do as in the contravariance, what happens? Either it can have a list of number or any a list of superclass, any list of superclass, right? Whether it can be a list of object. So superclass to number is like object of it. So what I'm going to do, I'm going to take this copy method. I'm going to create here list of object. Okay. So I'm going to create here list of object. So object list. Okay, I have created this. And similarly, below, what I'm going to do, I'm going to create list of number. I'm going to create list of list of list of list. Okay. So we have an object list. So if I call this copy method, which is static. So if I call this copy method, so I have taken this int list and object list. So as we know, like it can accept either the list of number or any superclass. So superclass is the object. So we are proceeding with the list of object. There is no issue, right? There is no issue. So if I copy it, copy it and paste it here. So instead of object, I'm taking a number list. So it can take like I'm saying that whether it can take number list or it can take any superclass. So there is no issue. As you can see, there is no problem. Okay, there is no problem. But we already know like we can know to perform the reading operation in the case of contravariance, right? We cannot perform a writing operation, not only reading is allowed, but writing is not possible in the case of covariance. So, but in the case of contravariance, we can perform the writing operation. So we can write here, writing is allowed. Writing is allowed. Writing is allowed. Why writing is allowed? Because number. So number is again a superclass for all the numeric value like integer, float, right? And object is also the superclass. So have it can be available there like so writing is allowed because you can write here because but but there must be either list of number or any subclass okay any subclass any list of subclass any list of subclass okay. So if I take the enhancement, let's say I'm taking a number so if I'm taking a number source and source, so reading is allowed in the case of so in the case of covariance, reading is allowed. So what I'm going to do to this destination, I'm just going to copy. I'm just going to add. Just a second. And back to this console. So to this destination, I'm going to add each and every. Okay. So as you can see, there is no issue. And if I run it, if I run both of the list, so let's check we have copied or not. So we have an offset. First, we have a list. So if I run this, let me see. So as you can see, this has been copied, right? Data is copied. We have copied the data. Got it? Got it, everyone? We have not a linked list, we need to put here long list. Therefore, it will be long list. Okay. So if I run it, you can see that. Okay. This is how we have done. I hope this point is clear. So in the case of contravariance, only writing is possible, but reading is not possible. But in the case of covariance, right, writing is not possible. Writing is not possible. Reading is possible. So like covariance is also known as upper bound, and contravariance is known as lower bound. Okay, so most of the time, interviewer can also ask about what is called upper bound and lower bound in Chinese. Got it? I hope this point is clear to everyone. Thank you. Thank you.